Good morning, boys and girls, and welcome back. Today we're doing our third day of integration by substitution. And today we're just going to take the stuff we learned the first 2 days and we're going to apply it now to a definite integral versus indefinite integrals. All right, so now we got limits on our integrals. Okay, so when we practice the same idea here, we're trying to undo chain rule. So I'm going to look for it inside for my u. So like in this case here, maybe let's say u equals x squared plus 1. See how that works out for us. Du then would be 2x dx. And so we look at the problem here, 2x dx, that's working out real nicely for us. So we're pretty much set to go. This is going to work well. The only thing you got to work out when you're talking about definite integrals, and we started doing this, 2x dx is our du, x squared plus 1 is our u squared. The only thing you have to watch out for, we said, when we're doing this u sub, integration by substitution, we wanted everything in terms of u. And when we say everything, again, we mean everything, including our limits. These limits right here in terms of x. Notice when I rewrote this one, I didn't put limits on there yet. In this case, I don't want to go from 0 to 2 because those are x limits. Okay? I need to get my limits in terms of u. And so, real easy to do that. All I do is I'm going to plug these x values over here into my u equation. So 0 squared plus 1 is 1, and u equals 2 squared plus 1, which is 5. And so I actually want to integrate this from 1 to 5 and not 0 to 2. Okay? And this will save me from having to plug, like when we did the indefinite integrals, we had to plug the x's back in, at the very end. This will save me from having to plug back in and writing something that's really mathematically incorrect. If I use 0 and 2 here, this is not the same integral. And again, where we can get ourselves into trouble is when we're kind of, lazy mathematically and trying to shortcut stuff in a way, but you end up saying things that are not true. And that's where AP will penalize us, okay? So if you ever do u sub, if you ever write things in terms of u, and this is frequently a point on a free response question, is to make sure that your limit's in terms of u. Okay? So now we're just going to integrate this from 1 to 5. I would say this is a couple little things here. Sometimes you guys try to do ln with 1 over u squared, but that's really u to the negative 2 du, and this is just power rule then, right? U to the negative 1, evaluated, divided by negative 1, evaluated from 1 to 5. So this is negative 1 over u evaluated from 1 to 5, which is negative 1/5 minus negative 1 over 1, f of b minus f of a. So negative 1/5 plus 1 gives me 4/5 as our answer. All right? So that's it. I mean, overall, very similar to the days before. It's just we now need to make sure that when we have our limits, we write them in terms of u. All right, so here we go again. Another example here. And again, that last one, not real hard, I think, not real bad. As you do these things, as we start mixing more stuff, I think that the real hard part about this is identifying, again, what you're trying to do, the integration technique we're going to use. Especially in this class, we're going to pick up a whole bunch of different integration techniques. And so it's like, hey, which technique do I want to use to integrate this problem here? And again, I'm going to say that, on this problem here, on the u sub problems, what you want to look for is an inside. Okay? And I know on this one, that's why this one's a little tricky because I don't really see an inside. But don't forget, like, you could rewrite this, and if this helps, when you see cosine squared x, that is cosine x squared dx. And so it helps you to rewrite it that so you see the inside, or get used to noticing that that really is an inside one, or a case we would use chain rule. And so this is a place that we want to use u sub as our integration technique. All right, so to do that, u is the cosine x, du then would be, the cosine is negative sine x dx. And again, making me feel good because we're fairly lined up here. I might just want to say, hey, negative du is sine x dx. Now it matches exactly, dividing both sides by that. We can come back now and rewrite this integral. Again, I leave my limits off to begin with. The integral of sine x dx is negative du, and I frequently just put that on the top. And then this becomes, again, u squared. Okay? Now, once you have that taken care of, now you just need to, again, change your limits. Those are limits in terms of x. So as soon as I go to u, I've got to change my limits in terms of u. If I plug u as cosine of 0, cosine of 0 is 1. So I've changed that limit. U equals cosine of pi fourths. And cosine of pi fourths is root 2 over 2. So this is root 2 over 2. And that really is just like saving me a step down the road if I were to go back and turn to x's. Okay, now that I do this, again, this is really negative integral 1 to root 2 over 2 of u to the negative second du. So negative times add 1 u to the negative 1 over negative 1 evaluated from 1 to root 2 over 2. Running out of room. Equals, this is really now negative. Negative is a positive. So this is 1 over u divided from 1 to root 2 over 2. So this is 1 over root 2 over 2 is 2 over root 2 minus 1 over 1 is 1. And I would probably just stop right there. And I would leave my answer like that. Checking the book and matching my answer, they've got root 2 minus 1, which means that they went and simplified that radical. Either way, again, just make sure that you can match an answer if you need to. All right? Real quick lesson day. One more, and we are done for today. All right, here's our last problem for today. And it's really a shame we're not doing this one in class, and you're just going to watch it down the video. I'd like to watch you guys squirm with this one a little bit and try to figure it out. Again, I think the hardest part of this integration by substitution stuff is figuring out what that, what does u have to be. And sometimes you just got to get in and you got to start playing with stuff. All right? So this one's kind of weird. So I'm going to play around with some stuff just to kind of begin with. Maybe I say, hey, u is, I'm looking for an inside part. 2x is an inside part, but I don't think that helps me. I've got a sine squared x, so maybe sine x is my inside part. And if I choose that, du then is cosine x dx. And I'm not, don't be afraid to jump into a problem and write something down, try it. Hey, that doesn't look like it's working. Okay, that's not quite right. Let me try, I don't know. There's all sorts of things we could try here. Let me try, hey, u is e to the sine squared x. Maybe let's try the whole thing. I don't know, maybe that'll work out for us. But then du would be e to the u with e to the, and I need another e. I mean, you can quickly see that that's not going to work. My point behind doing some of this false starts, bad starts, is it's okay to start incorrectly. Okay, that's fine. A bad start is better than no start at all. All right? If you keep playing around, you will wind up in the right spot eventually. In this case, I think what we're going to want to use, I'm going to try this again. We'll try to be good this time. I'm going to use sine squared x, or sine of x, I'm even going to write it like that, squared. Okay? I'm going to use that as my u. This part right up here, all that is my u. So if I do that, then du is 2 sine x cosine x, 2 sine x, chain rolled over the inside, cosine x, dx. And you might be like, well, that doesn't look like it's helping us very much. But again, you got to keep in mind our trig identity that 2 sine x cosine x is equal to, this is our double angle, sine 2x dx. So that actually does work out nicely because I do have that sine 2x dx. So that's what I did want to use for my u. And we can take this is what I love about integration by substitution. You take this big, long, crazy integral, and now we're going to do the integral, I'm going to leave the limits off, of e to the u du. And that is way easier and going to be way nicer to integrate. I just need to change my limits now, again in terms of u. Sine of 0 is 0, 0 squared is 0 still, so that one didn't change. Sine of pi over 4 is root 2 over 2. Root 2 over 2 squared is 2/4 or 1/2. All right? But always make sure if you're going in terms of u, change your limits. I can't stress that enough on today. That's the biggest thing we got to be careful of. All right, and so now an antiderivative of e to the u is e to the u, evaluated from 0 to 1/2. And then, so this is e to the 1/2 minus e to the 0, or this is the square root of e minus 1. And there we have it, boys and girls. That's it for today. Okay, hope you enjoyed it. Get after it. If you got questions, track me down. Otherwise, see you later. Have a nice day.